Welcome to the deep dive. We're here to cut through the noise, bring you those core insights from important research, make them clear, make them useful for you.
Exactly. No information overload, just those aha moments.
Today, we're tackling something really crucial. How do we know if educational intervention research is, well, any good? Is it trustworthy? Does it actually tell us what works?
hmm And our guide for this dive is a really foundational 1994 article. It's from the Educational Psychology Review by Joel R. Levin.
Think of this as like getting a toolkit, right? A way for you to look critically at all those claims about the best way to teach or learn.
Yeah, our mission today is really to unpack what makes this kind of research strong. Strong scientifically, but also, strong in terms of its actual value in a real classroom,
And we'll focus on two key ideas Levin lays out: research credibility
which is basically is a science believable,
and research creditability.
which asks, does the research tackle important educational stuff in the first place?
Okay, so first things first. Is there actually a problem here? Levin seems to think so. He mentioned some pretty strong words from Presley and Harris: maltreatment, drastic remediational measures.
Whoa, yeah. They were basically sounding an alarm, weren't they? Saying a lot of the research just wasn't giving us reliable answers.
And Levin supported that view.
Oh, absolutely. His article backs them up. And he wasn't new to this. He mentions he'd been working on improving research design and analysis in education since like the late 70s.
So it wasn't just a sudden complaint, it was part of a longer effort.
Exactly. Trying to bring more rigor, more meaning to the field.
Okay, so one of the big issues they get into is what Levin calls the control group problem. That sounds pretty fundamental to, trusting the results.
It really is. He even shares a story from when he was an associate editor, reviewing vocabulary research.
What was the issue there?
Well, he saw a real lack of consistency, a lack of rigor in how researchers were setting up their control groups, the groups not getting the new teaching method.
Ah, right, the comparison group.
Exactly. He was looking at this paper on vocabulary strategies, something he knew a lot about from his own work, and he realized how much the choice of control group could totally change how you interpreted the results.
He talks about different types they used in their own work on the keyword method. Free study, extra exposure, repetition controls.
Yeah, and it's striking, isn't it, how effective a new method looks depends entirely on what you compare it to.
Right. If you compare it to a group doing basically nothing, it might look amazing.
But compare it to a group using a solid existing technique, maybe not so impressive.
So the control group is the benchmark.
Precisely. If your benchmark is weak or, just inappropriate, you can't really say much about the true impact of your intervention.
So a free study control. Kids just study normally.
Yeah, that gives you one kind of comparison.
Yeah.
A repetition control, just repeat the words, that's different again. And an extra exposure control tries to match the time the intervention group gets.
It really makes you see how thoughtful researchers need to be about that comparison.
Definitely.
Yeah.
What are you really comparing against?
And then he brings up closet controls. No exposure controls. That just sounds weak. Like comparing something to nothing.
Exactly.
Yeah.
Levin points this out, and it goes way back to Campbell and Stanley decades ago. Comparing an intervention to absolutely nothing introduces all sorts of potential explanations.
Confounding variables, right?
You can't tell if the improvement is because of your great new idea or just because one group got some attention and the other got zero. This is a basic design flaw.
He uses that Oz analogy, which is pretty memorable. Repetition controls are straw people.
Easily knocked over.
Free study is a tin person.
A bit more solid.
Extra exposure is a lion.
A real challenge.
And closet controls, just yellow bricks.
Yeah, just lying there. No resistance at all. So if a study boasts about beating a yellow brick control,
He should be skeptical.
very skeptical. It doesn't tell you if it's better than what teachers are already doing.
Okay, changing gears a bit. Levin mentions this informal survey he did with his grad students about the Presley-Harris article itself. What did they find interesting?
Well, what jumped out at all four of them was the response rate. Only 55% of the researchers and editors Presley and Harris surveyed actually responded.
Huh. Only 55%. For a select group you'd think would be really engaged.
Yeah, that's what the students thought. It suggested, maybe, that these critical issues weren't getting the attention they deserved. Perhaps people were just too busy.
That is kind of ironic. The very people whose work is being discussed Only about half chime in.
It does make you
Wow.
wonder. But the students also noticed another tension.
Oh,
Presley and Harris said they weren't going to get super technical with statistics in their critique. They wanted it accessible.
okay.
But at the same time, the survey respondents, and Presley and Harris too, pointed out that many published studies lacked enough detail for others to actually check the stats or reanalyze the findings.
So it's a bind. Avoid complex stats, but then complain there aren't enough stats provided in the original papers.
Exactly. It's that tricky balance in science communication, isn't it?
Yeah.
You want clarity, but you need the details for proper scrutiny. Without those details, the credibility is questionable, no matter how interesting it sounds.
Right. Which brings us nicely to another pillar, statistical issues. Levin talks about type I, type 2, and type 4 errors. Why are these so important for us, the non-statisticians, to grasp?
Okay, so these errors hit right at the heart of statistical conclusion validity. Basically, can we trust the conclusions drawn from the numbers?
Makes sense. So type I.
Type I is a false alarm. You conclude there's in effect a real difference when actually, oops, it was just chance.
How does that happen?
Levin points out a few ways. The publication process itself tends to favor significant findings, so there's a bias there. Researchers might accidentally misuse stats, violate assumptions, and then there's fishing expeditions.
That's right.
Yeah, running tons of tests until something looks significant without a clear plan beforehand. P-hacking, some call it now.
He had a classroom exercise on this with
Right.
random data.
Yeah. Apparently, it was really effective, gave students totally random data, told them to find significant results using standard software.
And they did.
Almost always, just by chance. He mentions the magical number 7, like, if you compare about 7 groups or variables in every possible way, you're quite likely to find something significant just randomly.
Wow. So a study reporting lots of significant findings without a strong theory might just be noise.
Could be.
Yeah.
And that's a problem, right? If a type I error gets published, schools might waste time and money on something that doesn't actually work.
Real-world consequences. Okay, so type 2, that's the opposite, missing something real.
Exactly, a false negative. You failed to detect a real effect that's actually there. Levin notes this tension where Presley and Harris critique studies needing huge samples for tiny effects, but also acknowledge, citing Cronbach and Snow, that even small effects can matter educationally over time.
Which brings up statistical power.
Right? Does the study have enough power, usually enough participants, to actually detect a real effect if it exists? If not, a valuable intervention might get missed.
Okay, and type 4. That one's less common.
Well, traditionally, it was about misinterpreting complex statistical interactions. But Levin uses it more broadly, I think more intuitively. It's a mismatch between the stats you ran and the conclusions you draw about the real world.
So the math might be right, but the interpretation is off.
Yeah. You might misunderstand what the numbers actually mean for teaching and learning. And he argues this kind of conceptual mistake can even lead back to type I or 2 errors down the line.
So it's not just about running the numbers, but thinking critically about what they mean.
Absolutely. Which leads us right back to Levin's definition of research credibility. How does he define that?
For Levin, credibility is simple, scientific believability. Is the study methodologically strong? Does it have high internal validity?
Internal validity, meaning you're confident the intervention caused the outcome, not something else.
Exactly. If there are other plausible explanations, the study lacks credibility. Simple as that.
And he specifically separates external validity generalizability from this initial credibility judgment.
Yeah, that might surprise people. Don't we want research to be widely applicable?
We do, eventually. But Levin's point is, you first need to establish a believable cause and effect link within your study. If that foundation isn't solid, worrying about generalizability is putting the cart before the horse.
Makes sense. He also separates statistical conclusion validity from credibility. Why? Seems linked.
His reasoning is interesting. He says, look, if the initial stats were bad, you might still be able to reanalyze the original data correctly if the data itself is sound.
Okay.
But if the design was flawed from the start, like comparing 2 existing classrooms without random assignment, no amount of fancy statistical reanalysis can fix that fundamental weakness. The lack of control, the confounding variables, they undermine believability right from the outset.
He uses that exact example, doesn't he? Intact classrooms lacking credibility.
Right, versus randomly assigning multiple classrooms, which has much higher potential for credibility because it helps balance out those pre-existing differences.
And he notes this isn't new, right? People like Hilgard, Thorndike, they cared about rigor way back when.
Definitely. The need for careful methods isn't a modern fad. Levin also mentions that traditional view, basic lab research, seen as highly controlled, highly credible.
While applied classroom research is seen as messier, less credible, a kind of one-dimensional scale.
Yeah, and he really pushes back against that idea and the related notion from Campbell and Stanley that there's always this harsh trade-off between internal validity, control, and external validity, applicability.
Like you can only have one or the other.
Right. He thinks that's too simplistic, too limiting. We shouldn't just assume that trying to make research relevant means sacrificing rigor. He believes we can and should aim for both.
Okay, that sets up credibility perfectly. Scientific believability. Now the other dimension, research creditability. What's that about?
Creditability is educational commendability.
Mm.
Is the research tackling important, relevant educational issues? Problems that matter in real classrooms? Does it have the potential for positive impact?
But, like you said before, just asking an important question isn't enough, right?
Not at all. High relevance is great. But if the research is poorly designed, low credibility, its potential value is shot. He talks about that fuzzy dimensional continuum again.
Where lab stuff is seen as maybe not relevant enough and classroom stuff is seen as maybe not rigorous enough.
Exactly. That captures the tension perfectly. We want practical research, but sometimes it feels like practicality comes at the cost of scientific confidence.
And that's the tension Levin wants to resolve with his two-dimensional model. Can you lay that out for us?
Sure, so forget the single scale or the fuzzy trade-off. Think of credibility and creditability as two separate independent axes, like on a graph.
Okay, two axes. Credibility, high-low, credibility, high-low.
Right. Creates four quadrants. Quadrant A, high credibility, maybe lower credibility. Think basic lab science. Methodologically sound, but maybe not directly about classroom practice yet.
Got it. Quadrant B.
The opposite. High credibility tackles a really important classroom issue, but low credibility. Maybe the methods were weak, poor controls.
Okay. Quadrant C.
That's the J in quadrant. Low credibility and low creditability. Methodologically flawed and not addressing anything very important. Waste of time, basically.
And the ideal. Quadrant D.
The perfect quadrant. High credibility and high creditability. Scientifically sound research focused on educationally valuable questions. That's the goal.
What's powerful here is that they're independent, right? High credibility doesn't mean low creditability or vice versa.
Exactly. That's the key insight. You can do rigorous science on important educational problems. It breaks that false dichotomy. Good educational research needs to be both credible and credible. Aim for quadrant D.
He uses those fun acronyms too. J and K for the bad quadrant, perfect for the ideal, helps it stick.
It does. And to help researchers get to perfect, he proposes the best possible design philosophy. This feels really practical.
Tell us about best possible. How does it counter the usual excuses?
Well, he contrasts it with the can't-do philosophy. Oh, it's classroom research, we can't randomly assign, or it's just too difficult practically. Excuses for weak methods.
Right. Levin says we need to change that mindset. So what's the best possible process?
Step 1. Start with a creditable question, something that genuinely matters for education.
Okay, important question first.
Step 2. Design the most credible study imaginable under ideal, utopian conditions. Unlimited resources, total control. Your gold standard.
Dream big, scientifically speaking.
Right.
But then reality hits.
Exactly. Step 3. Acknowledge the real-world constraints. List them all. School limitations, resources, practicalities.
Be honest about the limitations.
Step 4. Adapt the ideal design to create the best possible study you can realistically do, given those constraints. Make principled compromises that minimize the hit to credibility.
So it's about smart adaptation, not just giving up on rigor.
Precisely. And if new constraints pop up, it's iterative. Go back, reevaluate, design the next best possible credible approach.
So no throwing hands up, continuous striving for the best feasible methodology.
That's the core idea. And he reminds us there are alternative, credible designs, time series, crossover, multiple baseline, weightless controls that can often work in messy, real-world settings.
The main message being,
Credible classroom research does not have to be less scientifically credible. It just takes more thought, more creativity, and a commitment to that best possible standard.
this has been incredibly clarifying. So listener, key takeaways. What should you remember when looking at educational research?
Okay, number 1, always distinguish credibility. Is the science solid?
Yeah.
From creditability, doesn't matter educationally.
Yeah,
They're
yeah.
separate.
Don't confuse them.
Number 2, watch out for those common pitfalls, weak control groups, statistical errors. Be a critical reader.
Got it.
And number 3, Embrace that best possible idea. Whether you're doing research or just consuming it, demand rigor within the realistic constraints. Don't settle for easy excuses.
Fantastic summary gives us all a much sharper lens. Now, a final thought for everyone listening to mull over. How might understanding these ideas, creditability, the best possible approach, help you evaluate claims outside of education? In your work, in the news, anywhere, could it make you ask tougher questions about methods and significance, no matter the topic?
That's a great point. It's really about critical thinking about evidence, isn't it? Wherever you find it.
Exactly. Keep exploring, keep thinking critically. Thanks for joining us on this deep dive.